Okay, sorry about that. So we talked about in the last video how she could start with a 3x4 rectangular layer that would give her 12 cubes in each layer. So 12, 24, 36, 48, that would take 4 layers in all and would use up all of her cubes. The other option would be starting with a 3x5. That would be 15 cubes. 3 times 5 is 15. So she would have a layer of 15. The second layer would get her 30 cubes in all. The third layer would give her 45 cubes in all. But she has 48 of them, right? So she would have how many left over? She would have 3 cubes left over. And how many layers was that again? 15, 30, 45. That's 3 layers. And so we can see that the 3x4 is obviously a better option than the 3x5 option. So she begins to notice a pattern in the rectangular prisms that will package 48 cubes exactly, which is obviously what she wants. She does not want to have any left over. So let's look at this animation to see what she discovers about that. So she's going to arrange a base layer of cubes that is close to a square. And here's that 3x4 we just talked about, which is 12 cubes in all. And then she's going to add those layers until she uses 48 cubes all together. So we have 12, 24, 36, 48. After 4 layers, then she used up all 48 cubes. So in general, the volume of that rectangular prism, the number of cubes inside of it, would be the length times the width times the height. So we had 3 by 4 by 4. 3 times 4 is 12, times 4 is 48. So that's the pattern that she began to notice. So in question 6 in your notes, it says Dee remembers learning formulas for volume in school, and she jots down the following formula for her future reference. It says V equals BH. Now notice the B in this formula is capitalized, and we've talked a lot this year about the difference between capital and lowercase letters. V and B are both capitalized because they are things that will have to be calculated. V stands for volume. You have to do something mathematical to find volume. This capital B is standing for the area of the base. So it's not like the base length, like in an area of a triangle, 1/2 base times height. That's a lowercase b. That's a single dimension. This capital B is an area. It's the area of the base. So that's why it's capital B, to let us know it's something we're going to have to calculate. And then the lowercase h, because that's a single dimension. It's the height of the prism. So for a rectangular prism, since the base is a rectangle, we can replace base area with simply length times width. So the volume of a rectangular prism would be length times width times height. So our question in number 6 says, what are some possible sets of dimensions that she might have for using all 48 cubes? And so we talked about one already, the 3 by 4 by 4, because 3 times 4 times 4 is 48. See if you can come up with any other combinations of numbers that would also give you 48. So there are many of them. One you might have come up with is 2 by 3 by 8. 2 times 3 is 6. 6 times 8 is 48. So that's another proposed dimensions for her box, is a 2 by 3 by 8. And then, of course, the 3 by 4 by 4 that we've already looked at. And again, there would be more than that. Now, question 7 in your notes is a review. Remember, we found the area of regular polygons back in, I believe, topic 21 is when that was in. So this should be a review of those skills. If you'll pause your video here and answer question 7 in your notes, and then you can come back to the video to check it. Okay, part A is finding the area of an equilateral triangle. Remember, that's a regular polygon because all the sides and all the angles are congruent. So if you drew your regular equilateral triangle, all the side lengths are given to us as 5. Remember, to find its area, we drew in an apothem and a radius, creating this 30, 60, 90 triangle. We needed to know the apothem length, which is that segment that goes from the center to the midpoint here that's perpendicular to that side, the number of sides, which of course is 3 for a triangle, and the side length, which was given to us as 5. So to find the apothem, we have to use our special right triangle rules. Remember, the apothem goes to the midpoint, so this length is 2.5, half of 5. It's the long leg of that 30, 60, 90. So to find the apothem, which is the short leg, we would have to divide that by the square root of 3. After rationalizing, multiplying the numerator and the denominator by the square root of 3, we would get 2.5 square roots of 3 over 3. So then we could find our area, which is simply 1/2 the apothem times the perimeter. And perimeter is number of sides times the side length. So 1/2 times all these values we found here. So exactly the area would be 6.25 square roots of 3 square centimeters. 1/2 times 2.5 over 3 times 3 times 5 is what you would put in your calculator. Don't put in the radical unless you're given rounding instructions. Now, part B is finding the area of a regular hexagon. So again, you would need to draw that figure and again create your 30, 60, 90 by drawing in an apothem and a radius. This time the 60 degrees is there at the vertex and the 30 degrees at the center. So since we're given the side length to be 2, when we draw our apothem to the midpoint, we know this side of that right triangle is only 1. That's the short leg. We want the apothem, which is the long leg, so we simply multiply by the square root of 3. So our apothem is the square root of 3. Our number of sides, since it's a hexagon, is 6, and we were given the side length to be 2. So our area is 1/2 the apothem times the perimeter, which is number of sides times side length. So we get 6 square roots of 3 square centimeters. We're going to need this information in just a moment when we start looking at volume of prisms. So it says Dee realizes that the volume formula she's using for rectangular prisms can also be applied to any right prism, no matter what the base has as its shape. The volume of a prism is in general terms written as volume equals capital B, which remember is the area of the base, times lowercase h, which is the height of the prism. So in order to use the volume for prisms with different bases, she has to know how to find the area of the polygonal bases, which is why we just reviewed that. So using your computer, you're going to go to AgileMind, which again is russellville.agilemind.com. Go to topic 24. Under Exploring, you're going to go to the title Packaging Sugar Cubes, and you're going to go to page 5, and you're going to answer question 8 in your notes. So you're going to, on this page right here, this is page 5 of Packaging Sugar Cubes, you're going to change your base to a square, equilateral, and regular hexagon, because that's what's asked for. You're going to change the dimensions to match what is given in the problem, and you're going to find the base area and the prism's volume. And it says to round your answers to the nearest tenth. So you can check them here to make sure you're correct. And then when you're finished, you can restart the video and we will check your answers. Okay, so remember the base areas on the equilateral triangle and the regular hexagon. We found that in number 7 in our notes. So all you really had to do was put that in your calculator and round those answers to the nearest tenth. So on the square, if the base side is 3, then we know base times height would be 3 times itself, or 3 squared, which is 9. So to find the volume, all you have to do is take these base areas and multiply them by the height. Now remember, don't ever use a rounded answer to do that because you're getting farther away from the accurate answer. So you would need to take your non-rounded answer, 6.25 square roots of 3, and multiply it by 4, and then round it. So 6.25 square roots of 3 times 4 is 25 square roots of 3. Then put this in your calculator and round it, and you get 43.3. Here we don't have any rounding to worry about. 9 times 5 is simply 45. And then here, 6 square roots of 3 times 4 is 24 square roots of 3. We can put that in our calculator, round that to 41.6. So remember, base areas is always square units, but we're multiplying it by another dimension. And so when we get our volume answers, those answers will always be in cubic units. So like centimeters cubed, feet cubed, miles cubed, etc. So on number 9, it asks us to find the surface area of the box. So this is not volume. This is not length times width times height like we would do for volume. For surface area, it'd be like if you're wrapping a package or painting it, the surface that would be covered in that paper or paint. So you can see we have the net of that rectangular prism that is shown here, and that net allows us to see all the two-dimensional figures that make up the faces of that prism. And so we can simply find the area of those rectangles and add them together. Well, notice this rectangle right here is a 6 by 2. We have another one on the other side of the box, and so we have two of those that would be 6 times 2. So we have two of the 6 times 2 boxes. And then we have these two rectangles here that are 4 by 6. This one's a 4 by 6, this one's a 4 by 6. And so we're going to add that to the two we already have. So we have two more that are at 4 by 6 as its area. And then our last two rectangles are this one right here, which it tells me this is 2. So it's 2 by, we already have this dimension, it's 4. So we have a 2 by 4 here and another 2 by 4 here. So we have 2 of the 2 by 4s. So we have 6 faces all together. They're all rectangles. Oops, not plus there. That should be a multiplication. Sorry about that. 2 times 4. And, that's a multiplication dot. So you can see here we have those 3 numbers that are our length, width, and height. So we have 2 of them that are 2 by 4s, 2 that are 4 by 6s, and 2 that are 2 by 6s. So you're doing 2 that are length times width, 2 that are length times height, and 2 that are width times height. And so 6 times 2 is 12, times 2 is 24, plus 4 times 6 is 24, times 2 is 48. And then we have 2 times 4, which is 8, times 2, which is 16. So we're just adding those 3 areas together. And so 24 and 16 make 40, plus 48 is 88. Remember, since we're back to area, that our units are squared, not cubed like they are for volume. So this would be 88 square centimeters as our answer there. All right, so we looked at prisms and cylinders today. You can see examples of both in your everyday life. Prisms, I'm sure you have lots of boxes at your house, like cereal boxes, in fact. And cylinders, maybe you have cans of soup at your house, or one of those containers that has oatmeal in it. Those also are typically cylinders. So your homework is assignment 24.1. Good luck.